The first topic under stoichiometry is the mole concept. First, let us define mole. It provides a specific measure of the number of atoms or molecules in a bulk sample of matter. Easier way to express amounts of reactants and products of chemical reaction. It is also the fundamental unit in the System International that is used to measure the amount of substance. The mole provides a connection between an easily measured bulk mass and an extremely important fundamental property, number of atoms, molecules, and etc. The number of entities composing a mole has been experimentally determined to be 6.02214179 times 10 raised to 23, a fundamental constant named Avogadro's number.
Now let's discuss molar and molecular mass. The SI unit for molar mass is gram per mole, since by definition it is the amount of substance in grams per unit mole. It is considered to be a mass of a mole of molecules. Meanwhile, molecular mass is measured in atomic mass units and can be defined as the mass of one molecule. These two units are technically not the same. However, interchanging the same values will not bear complications during computation. To get the molar or molecular mass of a given substance, if it is not given, you simply have to get the atomic weight of each element present and multiply them by their subscripts, then get their total.
The relationships between formula mass, the mole, and the Avogadro's number can be applied to determine the various quantities that describe the composition of substances and compounds.
Now, let's move on to our next topic, which is empirical formula and molecular formula. Molecular formula is the exact chemical formula that shows the actual ratio of atoms. Now, let's move on to our next topic, which is empirical formula and molecular. How to get molecular formula? First, we have to get the empirical formula. Step 1. Change percent to grams. Step 2. Convert grams to moles. Step 3. Divide the values by the smallest number of moles. Step 4. Write empirical formula. First, we start with the number of grams of each element given in the problem. Next, we convert the mass of each element to moles using the molar mass from the periodic table. Then, we divide each value by the smallest number of moles calculated. Then last, we round to the nearest whole number. Now, let's solve for the molecular formula. Step 5. Find molar mass of the empirical formula. Step 6. Divide MF molar mass by the EF molar mass. Step 7. Multiply the whole number to the subscripts of the empirical formula. The simplest formula for vitamin C is C3H4O3. Experimental data indicates that the molecular mass of vitamin C is about 180 grams. What is the molecular formula of vitamin C? Step 5. Find molar mass of the empirical formula. Step 6. Divide MF molar mass by the EF molar mass. For the last step, multiply the whole number to the subscripts of the empirical formula. Now we're done, and the molecular formula of vitamin C is C6H8O6.
On to the next topic, percent composition by mass. There are two ways in calculating mass percent composition. Here is an example to better understand the use of the given formulas. Now for the solution. First, find out the atomic masses of the elements from the periodic table. Second, determine how many grams of each element are in 1 mole of potassium permanganate. After getting all the grams of each element, add the grams together to get the mass of 1 mole of potassium permanganate. Then, get the mass percentage for each element using the formula. It is always good to check if your answers add up to 100%. Some answers are still accepted as long as it's in the plus-minus 0.02 range. Tips for calculating mass percent. Total mass is not always given. You would have to add up the masses. Be careful with significant figures. Make sure that some of the percentage add up to 100%.
Now we're down to our last topic, finding the empirical formula using percent composition. Finding the empirical formula is basically the reverse process of finding the mass percent composition. Instead of solving for the percent composition, we will be using it to form the empirical formula of an unknown compound. Here's an example. In a chemistry class, citric acid is said to have 37.51% carbon, 4.20% hydrogen, and 58.29% oxygen in a 100-gram sample. Find the empirical formula. The first step into solving this problem is to convert the percentages into grams. To do this, you must multiply the given percentages to the given mass of the sample. Since we have a 100-gram sample, the percentages will automatically be converted into grams. Second, we must convert the grams to moles for each element. To do this, we must multiply 1 mole over the molar mass of the element. Now, the third step is to divide the moles with the smallest number of moles to get the whole number ratio for each element. As we can see here, 3.12 is the smallest among every mole in the problem. After dividing this, we get 1, 1.4, and 1.17. Since we can't have decimals in the empirical formula, we must multiply numbers to get a full number for every element. Now this is purely trial and error. So here, we try the number 3. We get 3, 4.02, and 3.51. 4.02 is already near 4 because of the margin being plus minus 0.1, but we still have 3.51. Even though it is 0.5, we still can't round this since this is not within the margin. So we try multiplying another number. Here we try 2, and we get 6, 8, and 7.02. Now, 7.02 is already near the margin, which is plus minus 0.1. So the final answer is C6H8O7.